Alright, your last day in notes. We're going to look at angles of elevation and depression. Make sure you pay careful attention because I'm going to have you guys probably do the last 2 or 3 problems on here for tomorrow. So we'll see how it goes and we'll see what time we're at. But like I said, probably the last couple that you guys are going to do. Good part about this is we've done everything we've needed to in terms of trig. Now it's just adding in a couple of vocab words that we've actually already talked about. We've talked about elevation, we've talked about depression. So you want to be able to use those couple of keywords to set up triangles and then solve for missing lengths and then maybe sometimes missing angles. So if we look at this, I have a little picture here. Angle of elevation is in this case x, and it's always inside the triangle. Angle of depression is y, and it's always outside the triangle. However, we talked about before, the angle of depression and the angle of elevation are always congruent because they're alternate interior angles. So for example, if this is 30 degrees, so is this. So if you're given the angle of elevation or depression, you're still going to put it right here where x is. Okay, because again, they're going to be the same. So let's just try some problems, and then I'm going to have you guys try some on your own. A person in a 21-foot tall lighthouse, so we're drawing a little lighthouse, and again, I like to draw it somewhat, accurate. I try my best. So here's a little lighthouse, and there's your little light at the top. Spots a boat in the distance, so here's our boat. Pretty high tech. Of course, it's in water. The angle of depression is 30 degrees. How far is the ship from the lighthouse? So again, the lighthouse was 21 feet tall. The angle of depression, so we know we're building the triangle down to here. And again, angle of depression is based off of this horizontal. So this is 30 degrees, which means this is 30 degrees. Okay, so now we're just focused really on this triangle here that I'm going to outline so we can see what we're really focused on. Okay, so there's our triangle. And again, we want to find out how far is the ship from the lighthouse. So we want to know what that is. Okay, SOHCAHTOA. We're still using SOHCAHTOA. Now, instead of special rights, we're using trig. So if we start at 30 degrees, because we always start at the angle, I guess if you wanted to up here, you can say that's 60. But we're starting at 30 degrees. And we can say, okay, if that's 30, we want to compare our known and our unknown. So our known is 21, that's opposite. Our unknown is adjacent, that's x. Adjacent, opposite, which one is that? Hypotenuse is not involved in tangent. So we're going to say the tangent 30 equals opposite 21 over x. This is the one that in that Getting Triggy with the video where the x and the tangent of 30 just switch, or you can take the long way, which is fine for now until we see that. Divide back the tangent of 30 because that's just a number. Don't let it scare you. So x comes out to be about, let's go ahead and round everything to the nearest tenth. So I'm going to punch this in, 21 divided by the tangent of 30. Make sure you're in degrees. And you get about 36.4. Give me a unit so I know what you're talking about. And there you go. So it's just what we've been doing. It's more practice with the trig, just involving word problems. Okay, number 2. And feel free, if you want to work ahead to test your skills on this, these are all going to be just word problems. A young man is meeting his date at the signature room at the top of the John Hancock. Alright, so let's get this John Hancock building going. Okay, that's not the Sears Tower. This is the John Hancock. Okay, all these little windows, whatever. Doesn't matter. Okay. He is running late, and he can see the top of the building. So here he is. And he's running. So it's going to be a little stick figure that's running. Okay. Here's our little road he's running on. He's running late, and he can see the top of the building. He remembers reading that the building is 1,127 feet tall. Okay, so he has a really good memory that he can remembers that as he's running for a late date. The angle of elevation is 88 degrees. How far is he from the entrance of the building? Okay, so what we can really do, since this entrance is the same, we can make a triangle there. Now the problems are different. We've looked at ones where you have to add in their height. We don't care about that because we're not looking at the height of the building. We're just looking at how far he is away. So it doesn't matter if you're talking about the distance from the feet to the bottom of the building or from his face to the bottom of the building. It's going to be the same because you're just talking about distance away from. So we have everything we need, and we can go ahead now and say, alright, the angle that we are starting at, angle of elevation right here, is 88 degrees. We want to know how far he is away. So we're starting at 88. We have, again, the opposite, and then we have the adjacent, so that is tangent of 88 equals opposite over adjacent. Again, this is where it switches, and I'm going to do the switch just so you guys can see it. And all it is this. That's what we've been doing the whole time. So if you're comfortable, go ahead and do it. If you're not, don't do it. 1127 divided by tangent of 88, and we get about 39 point, it's rounded up to 4 feet, and there's our answer. Okay, so again, you're just drawing a picture and then working off it. A fire is sighted from a fire tower in Wayne National Forest. The ranger found that the angle of depression to the fire is 22 degrees. If the tower is 75 meters tall, how far is the fire from the base of the tower? So we've got this little tower here. Okay, and the tower is 75 meters. We know we've got a little fire down here. Okay, let's get in some little yellow, a little bit of red. This is probably one of my best pictures. And we see, okay, we want to know how far is it from the base, so that's our x. And the angle of depression, so we have our little triangle here, the angle of depression, if you think about it again, is 22 degrees, which means this is 22 degrees. Okay, again, if you want to find that freebie angle at the top, you could go ahead and do that. That's going to be 68 degrees. You don't need it, but you could have it if you want it. And now again, it's starting at an angle, so starting at 22, compare 75x. You're going to find a lot of the times that we do use tangent with these types of problems, but not always. So we're going to have the tangent of 75 equals opposite. I'm sorry, whoops, tangent of 22, whoops, getting ahead of myself. Tangent of 22 equals opposite over adjacent. And again, I'm going to go ahead and flip-flop these because that's really what's going to happen. If you don't trust it, go ahead and work it out. I'll let you guys punch that in. 75 divided by the tangent of 22. And we get about 185.6, and that was meters. And you're done. Picture, set up your triangle, solve. A mall escalator. Okay, Janelle and Alicia, make sure you're paying attention. A mall escalator is 80 feet long. So we know that we have this little escalator. I don't know why I drew it this way. It's just the way it's going to go. It's 80 feet long. If it rises 32 feet, find the angle it makes with the floor. So now you got to be a little bit careful. So we know we have this escalator. It goes up 32 feet. The escalator is 80 feet long itself. That doesn't mean this is 80 feet long. That's not what we're talking about. We're talking about the actual escalator that you would stand on. It's 80 feet long. So that's where you have to be a little bit careful. We want to know, find the angle it makes with the floor. So we want to know what this is. Okay, so now we're finding an angle. Hopefully a bell just went off inside your head that said, wait a second, we got to make sure we do inverse when we get here. You are correct. So let's look at this. We have, again, across from x is opposite, so that's 32. And then across from the 90 is your hypotenuse. So we don't have an adjacent. Adjacent would be right at the bottom floor. So we're going to use opposite hypotenuse. That is your sine of x equals opposite 32 over 80. Again, this is where you're thinking it's like dividing by sine to get x by itself, but really all we need to do is take the inverse sine of 32 over 80. So we get x, and we'll go up to the nearest degree. The inverse sine, you guys are probably already ahead of me, 32 divided by 80. And you get about 23.57, so we'll call it 24 degrees there. Okay, no unit, just make sure you have degrees. Alright, moving right along. I think I'm going to have you guys probably do 6 and 7, and then maybe we will do 8 for a warm-up. So maybe 6 and 7 for tomorrow. Number 5. The Leaning Tower of Pisa is 179 feet tall. So let's draw this little leaning tower. Okay, and again, windows all the way up, or however it's done. We'll just make it look good. So there's our Leaning Tower of Pisa. It's leaning slightly. It's 179 feet tall. It makes an angle of approximately 85 degrees with the ground. So right here, it's not 90, it's 85 degrees with the ground. About how far over does it lean? Hint, drop in altitude from the top of the tower. Okay, so we have to think about this a little bit. So this is 85 degrees. We don't want to work with that. What we do want to work with is a 90. So now we have this really narrow triangle. So I'm going to go ahead and redraw this so we can see exactly what we're looking at. So really we're just focused on, here's the ground, here's the right angle. That little triangle I just took out here, it was just this. And this is 85 degrees here. This is 179 feet because it's leaning over. We want to know how far over does it lean. So what's that distance that the top leans out over? So we want to find that guy. Okay. We could start at 85 if you want to. You could start up here and work on 5 degrees. I'm just going to go with my given because I know it's right. So we have 85 degrees. We have x, which is next to it, or adjacent. We have 179, which is the hypotenuse. Adjacent hypotenuse, that is your co, or your cosine of 85 equals adjacent x over 179. This is the one where you're going to go ahead and cross multiply. Nice and easy. So that equals x. And now let's go ahead and punch that in. 179 times the cosine of 85. And the Leaning Tower of Pisa leans over at approximately 15.6 feet, or 15 and a half feet. So that's quite a bit if you think about a building leaning over there. Okay, so that's 5. So we've done quite a few. You can go back, you can rewind and look at anything we've done. Okay, you have everything you need here. It's just angle of depression, angle of elevation. I want you guys to have done, so that means they're done before you walk in tomorrow. I want you guys to try 6. I want you to try and do 7. So there's a couple extra steps on there. I'm going to get you guys started on 6. An observer on a cliff 800 feet above sea level sights 2 boats due east. So we have 2 boats over here. Again, here's our little water. The angle of depressions of the boats are 47 degrees. And then 32 degrees. Okay. So in other words, angle of depression is the same as angle of elevation. So this one is 47 degrees. This one's not as steep of a, oops, I have it mixed up. This should be 32 degrees because it doesn't open up as much, and this should be 47 degrees. Find the distance between the boat. Well, you need to do 2 trig problems. Do the first one, set it up, solve, just like we've been doing. Do the second one, set it up, solve. We actually have done a problem like this before, and then you find the distance between the 2 by subtracting. So find one time, maybe where you have this as x between here and here, and then set up another one where you have this and maybe as y set up from there to there. So set that up, and you guys can handle that for tomorrow. Do 6, and then again do 7. A balloon on a 140-foot string makes an angle of 70 degrees with the ground. How high above the ground is the balloon if the hand of the person holding the balloon is 6 feet above the ground? So again, let's go ahead and set this up. Balloon on a 140-foot string, balloons in the wind. It makes an angle of 70 degrees with the ground. How high above the ground is the balloon if the hand of the person holding the balloon is 6 feet above the ground? Okay, so you have to keep in mind that this is 6 feet. So this right here to the ground is another 6 feet. So you need to find that height from the top of his, where he's holding it, and add on that 6 feet at the end. So it's just one literally one extra step of adding 6. So do 6 and 7 for tomorrow. You have the pictures drawn, wonderful pictures for you to use. And then we will go ahead and do 8 tomorrow in class together. Feel free to work ahead on 8 if you want, though. Adios.